Hello.
Hi, everyone.
Okay, we were a little bit delayed. My name is Klaus. We will be introducing WindFarmDesigns in this webinar. Before we start here, well, maybe I should introduce myself. My name is Klaus. I develop WindFarmDesigns, which is a tool for layout optimization. And with me here.
Hi, my name is Vaibhav.
So, before we start the webinar, I think I'll just, this is quite new technology to us as well. I mean, the Google Hangout on here. You have in your upper right-hand corner, you can pose questions. So if you go to upper right-hand of the screen and you click an icon, you will get a menu where you can pose Q&A. So you can do that along the seminar. So we will be trying to answer as well as we can at the end of the webinar. Okay, so let's start with WindFarmDesigns. WindFarmDesigns is available through our webpage. So I will start sharing the screen. Like this, and screen number 2. Yeah. And what you can do is to log into windfarmdesigns.com, and you can obtain a user from there. You can either press get started, or you can sign in from this main page. So let's try get started, or sign in. You can also press. I already have an account, so I don't need to sign up. But if you sign up, I will try to answer as quick as possible, and it will be possible for you to try it out, the product. So I sign in here, and then you will come to the web application where you can start uploading. Now we have cheated a little bit, so we have prepared some tutorials for you. And see, you want to change the screen size?
We can maximize it.
Like this. Okay. Okay. So here you see the user interface. We have a map, and we have optimization history. We have a couple of projects already here under some of these folders. And on the top here, we have data where you will put in your project data. And on the tutorial page, I open this now. There's the description of each of these parameters you have to put into the page, and you can see we have two cases here. One case with elliptical optimization of the wind farm layout, and one where you only use the minimum distance, which is a circle constraint. So let's just download this case ellipse. Yeah. It's a zip file, and it contains, say, we have to unzip this file. Case ellipse, and well, what you basically need for our layout optimization as input data is you need a wind resource file, a VRG file. That's this one, and then you need a turbine file, or alternatively, you just need a spreadsheet or some turbine data with power curve and CT curve, and you can paste it into the program. And then you need a planning area that defines the area of the site. You could also put some more constraints, some constraint area inside the farm, or exclusion areas, but we are not including this in the example. So now you have downloaded these files. Let's go to project window where you're supposed to put in data. So let's start a new project. Let's call my project webinar test. And I want to optimize a layout. In this case, I would like to have a maximum number of 25 turbines in the layout. And I should define the UTM zone for my project. And the hub height, this has to also correspond to the VRG file. There has to be a height corresponding to this hub height in the VRG file, so you have to make sure of that. The rotor diameter corresponds also to the turbine I want to upload. And now you can choose the optimization type. We have one minimum distance criteria. You can either enter the number of meters, or you can enter as multiples of rotor diameters. Let's say 4.5 rotor diameters. You can enter that as 4D, for instance, 4D. We will try with an elliptic optimization. With 8 parameters should correspond to, I prefer to use 5 rotor diameters. And E is, or the transversal direction, I prefer to be 3 rotor diameters. You could choose not, or you could choose to let the program decide what's the prevailing wind direction, but it will do so for each point on map using the VRG, the information in the VRG file. But I would recommend you to have, or to decide what is the prevailing wind direction. So I try with 330 degrees as the prevailing wind direction in this case, because on some sites you actually have a change of wind direction, and that makes it hard to, or not hard, but you can put less turbines in if you let them be oriented along the wind direction and the wind direction change. Okay, so let's upload the VRG file. My folder was here, so I upload the planning. No, sorry, window resource climate, and I can choose the turbine. I will just show that you can edit a turbine file here, and you can use copy paste from Excel spreadsheet or something like that, and you can edit your own turbine information. At the moment we have, you just need to enter meters per second power curve and CT curve. There's no noise data as for yet, and here's the main information about the turbine. But let's just upload one turbine file. We are used to, since we are users of WindSim, we are used to the PWS format for WindSim. I can maybe show this in a separate. This is how the format looks like. So I'll upload this one. And then the last thing I need to upload is the shapefile that defines the planning area of the project. You can do it without the planning area also, I think. You agree on that?
Yeah.
Vaibhav? But of course it doesn't make sense if you have a defined planning area. So we usually have a planning area. Now you could actually also add some other constraints here in the form of a shapefile, or in the form of a CSV file that is actually points, exclusion points, that you can, for instance, generate from Park Optimizer or some other tool. Okay, so now I define my whole project, and I will my optimization, and I will send for calculation. So maybe you can talk me through what's happening now.
Yeah. So it takes a few seconds to upload the data, the files to the cloud, and while we are at it, let's just look at the.
I have also this one.
Let's look at what's happening so as to say, under the hood. When we are creating this, we're going to talk a little about very briefly about the infrastructure. So we run this on Google's cloud infrastructure. So when we submit or send the data to the cloud, what we do in the backend is start a virtual machine, what we call a Google Compute Engine instance. And this instance can be thought of as a virtual machine with all the prescribed softwares and programs that one needs to do wind farm design to solve this problem of getting a layout. Just to give you an overview, since we just started a case for an optimization, what we will see is an instance. It'll show up in just in a couple of seconds. There we go. So this is an instance which is performing our task of doing some pre-computations on the wind resource file, and then it's going to give us the optimized results eventually. Also, just so it's clear, this is mainly for developers, that there are logs where we can see what's going on. One of the primary reasons we thought we're using Google's cloud infrastructure is the scalability. The quotas can be scaled up almost instantaneously, and that gives us leverage when there's sudden spike in the demand. And so we are prepared to take care of that. Having said that, the fact that we've submitted or sent an optimization running, we will get an email confirmation when it's completed. And we can see a status here which says your optimization has started, and we can see the status, which is currently it's not done. It's working on it. We just thought of taking this time to point out that the parameters that we put. So some of them for the users help. We've set these values that people can run. So instead of having to remember all these details, you still need to download those files, but you can use the parameters that we've prescribed by choosing the tutorial and then going through them. Let's look at it. May be a few minutes before we get the results. I think it usually takes about 4 or 5 minutes for this case. But let's go back and see an existing project. So perhaps webinar 25, which we had run before, we could use that. So this is the projects. So on the left, we can see the optimization history and the projects we have. We can choose to download the results or view the results. So let's see. We've downloaded, but let's take a look at the results also. Let's look at the results on the with the Google Maps as a background. Just take a couple of seconds to load. Okay, so there it goes. What we have on the left is a list of layouts from 1 to 25. One of the better features of this software or this service is the fact that we give you layouts for all the turbines to your maximum, to the one you wanted. And we'll get into that in a little while to explain how that comes into play. So that's the planning area. Let's look at the energy map. So it's overlaid, and let's take a look at maybe the layout with 25 turbines. So I'll zoom out a little. So that's the planning area with the energy map and the layouts. We can click on any of the turbines and get some details about it. So this turbine is ranked 16 in terms of its production, and we can see its gross net annual energy production, and along with the wake loss. The wake loss we use for now is a simple Jensen model. Now you might not have noticed, but we've got an confirmation that the optimization is completed in an email, and I guess Klaus can now take over and describe why we have 25 turbines. And
yeah, okay. So you may wonder why we have, well, what we actually do here is to optimize several sizes of the project. We start with one turbine, optimize the position, then we do the same thing for 2 turbines, 3 turbines, 4 turbines, and so forth. And you may think that will take a lot of time compared to just, if you're just interested in, you want a fixed layout with 25 turbines. But it turns out that, well, it's a side effect of this algorithm we use, that it's actually faster to generate all these layouts and gradually build upon those. Although, let's say you have, in principle, if you have layout number 24 with 24 turbines, and you go for layout 25, you add another turbine. In principle, all the other turbines' positions could be moved. So you could, in principle, end up with a totally different layout because you have a distance constraint between the turbines. So where you put one turbine will affect where you put other turbines around, which in effect affects all the other turbines. So that's what makes this a complicated optimization problem that we are solving with formal operations with search methods. So what we can do now is to download the results to use them in further analysis for our tools. So let's say I'll download. I have let's see, 30 turbines here. 35. I can download these results. And we can have a look at how these results look like. Well, first of all, you have one layout file for each layout for each size of the project. So here you have for a size of 35 turbines in this project, this is how the layout looks like. And you have the coordinates, you have the gross energy production in gigawatt hours, and you have the weight loss also included, and you have that annual energy production. That's the gross minus the weight loss. The weight loss is not big in this case. That's because we have proper turbine spacing, 5 and 3 rotary diameters. So, and it's a large area, so we don't have much weight losses here. Another file that we will look at is what we call the energy curve. Now, the energy curve is actually the total energy output in terms of gross energy output and net energy output measured in gigawatt hours. As you can see, the first, if you only have one turbine, then there's no weight loss. If you have 35 turbines, there is some weight loss present here. This information can be useful for investment analysis, because on a complex site there is quite a large variation between the production from turbines from position to position. So it's a matter of when you squeeze in more and more turbines, then when should you stop? When does the weight loss and less desirable positions outweigh the benefit of adding more turbines? So let's have a look at layout. I have started WindPro here. I will just drag it to the screen. Take some time to load.
Maybe the spreadsheet.
Yeah, I'll try to show this layout first. Yeah. Okay. I just have to load WindFarm on the other screen here. It takes some time. Okay, here I have uploaded a couple of layouts. What you see here is layout 35, and I have 140 layouts. So let's have a look at this layout that we just inspected. I will plot now the elliptical distance to see how we are. Just to make a check. So for turbines, I just oh, I have a sequence. I think I'll plot the elliptical constraints. 5 rotor diameters.
Use 2.5.
Let's use 2.5. So that the tangent will be 5 rotor diameters for verification. Okay, so let's have a look at this layout. So we have now. I didn't plot the ellipse. Let's see. Just have to do it once more. I forgot to check this button here. Yeah, that's the problem. But the elliptical distance constraints. So, 30 degrees. Yes. Yeah. So now you can see the elliptical constraints here, and as you can see, it keeps the distance as according to the constraints. So that was the layout file that you can copy and paste into WindPro or any other preferred tool that you want to use for further exploration and wind farm design. Then we will look at this energy curve file. I will just upload a Google spreadsheet here. I think I need to log in. Where we will inspect the energy curve and see what is the optimal size of the layout, or what should be the optimal size of the layout. So I see there was coming in a question already. So while we're waiting here, then there was the question what's the biggest difference between the optimized function in WindPro and the new tool. Okay, now I will answer that just after having shown this result here. It's still loading. In WindPro, it's a heuristic algorithm. That's the first difference. That is an algorithm where you're not necessarily guaranteed an optimal solution, but it gives quite good results, and it's based on trial and error. It tries to place turbines in a more or less systematic way. With our algorithm, which is based on formal optimization techniques, it does guarantee optimal solution, but it only considers the elliptical distance and not weight losses at the moment included. But we have the elliptical distance, and as you can see, the weight losses are not very big. And when you compare the results with other tools that does include the weight loss but doesn't give, can't guarantee optimal solution within their definition, then this one performs quite good. The WindFarmDesign algorithm performs quite good. There are some other differences, but let's return to this example now. What I did was to upload this energy curve and plot this layout size in the first column, the gross and AP and the gross and the net production in the following columns. And what you can see, the blue line, that's the energy that increases as a function of project size. Now, if this was a flat terrain, then there was no difference where you put the turbines, and also there was no weight losses, this would be a straight line. But because of weight losses, this blue line is slightly curved. And also, if you go to complex terrain, there are less desirable turbine positions when you start to squeeze in a lot of turbines on a limited site. So it's easier to see this if I plot the marginal full load hours. This will be the marginal change in full load hours as the project increase by under one turbine. So you can see in the start, you have a higher marginal full load hour for one turbine, and then it gradually decreases. Now, if we had tried to squeeze in more turbines, at some point it will start tapering down here. So at some point here, you would decide that, well, it doesn't pay off to put that extra turbine in there because it doesn't pay off. The production is too low. So this can be used. I mean, this result here can be used to decide approximately what should be the proper size of this project. How many turbines can it squeeze in? This is important in complex terrain, but maybe not so important in flat terrain where the difference in production is not so big. So this curve would be more or less not so steep. This is not the steepest curve I've seen. There are many more steep. I've seen examples with much more steeper curves than this one, but also have proper turbine spacing here. Okay, so that was two examples of how to use these results from WindFarmDesigns. We could mention that you can upload constraints that we talked about before. We could upload a shapefile as an exclusion part of the site, and also as a CSV file can also be accepted. I used to do this when I run Park Optimizer. I use WinSim for wind resource assessment, and I use Park Optimizer to generate exclusion areas from shear, from flow inclination, from turbulence, and those results can be exported, and I can continue using them in an optimization like this. So what we have done so far is to focus on elliptical constraints and be sure that we can guarantee an optimal solution
for a range of layouts.
Yeah, for a range of layouts, but only with the simplified elliptical constraints. We have not added, or we don't compute a wake effect as part of this optimization. It's done is post calculated, but we compare the results, and we can see that the results are quite good still. We are working on the effect of this, but we think that turbulence is also a big challenge. So the spacing here is there's more issues than the weight loss when it comes to distance between turbines. Another thing we are working on is the road costs. We see that layouts are, when we did sensitivity analysis and made multiple optimizations, then we see that it's usually it's a relatively flat optimum, but we think that the road costs, which we usually consider manual outwards, can benefit from being included and as a joint part of the optimization. And we are curious to see how much that can benefit, or how much improvement we can get from that. So we are trying to do that, to implement that now. We also got some requests to include two turbine types. Often we experience sites where you want class 1 turbine and also class 2 turbines. In some areas you can accept class 2 turbines or you need to use class 1 turbines. So this is something we think is feasible with optimization algorithm to include. Although it will be a bigger problem, but we think it's possible to include it. And then the last thing is the noise, where we also have some ideas on how we can implement noise constraints. Yeah. So that's prospects we have for now, but we're curious to see what kind of improvements test users want to see.
Feedback from the users, and we're also open to any other questions you might have. We've got a question from one user. If there are others who want to ask, please use the Q&A application on the top right of your screen.
So I'll turn back to, let's see, I'll turn back to the user here. That. Okay. So I think I can answer that question. I said that, well, the biggest difference is that first of all, WindPro is based on heuristic algorithms. We use, so it's more or less trial and error, but it gives usually good results. But sometimes it can't. If you try to optimize with big layouts, big wind farms, it has problems in fitting enough turbines. It does not really do well in squeezing in enough turbines, even though there's enough space for that. Our algorithm can fit as many turbines as possible, but again, we are improving, or we are working on improving or including more realistic constraints like the road costs and also a more proper representation of wakes in our model. But I encourage you to try it out. You can try our algorithm, include it in WindPro, compare with the suggested layout that was optimized in WindPro, and you can have a direct comparison.
There's a technical question also on what kind of programming language is used for the cloud computation, and well, it's we use a mix of Python and some C scripts, and that's primarily what we're using for the computations. We have another library we're using for the optimization, and yeah, so it's these three put together.
Yeah, because so we use for optimization, we use four more optimization tools, and the two most prominent tools or solvers are the Express library and the CPlex library.
All the participants, all the viewers can get a free trial. We'll send out details of that in a little while, and we'd be happy to have you try it out and share your experience with us. Also about to run out of time, so I think we are.
Yeah, is there a more? I think I answered this one.
Yep.
Already, and also this one.
Yep.
I think. Yeah. So then we will put up some of the material here. We will put up on the on the WindFarmDesign site. We will make some additional page, and for instance the case studies and tests we can display on those pages. So
also probably the spreadsheet and so
yeah. So yeah.
Thanks for joining in.
Thanks for joining, and sign up for our test. We would like users to test it and see what they think about it.
All right. Thank you.
Goodbye.